Well, it's been a while since I made any of my videos with the construction of the training single. And again, it's a training single. It's not a racing single. And it's designed so that a novice rower who's never rowed before is able to get in the boat and not tip over. But at the same time, for someone who can scull, it will give you feedback. In other words, if you don't take your blades out cleanly, the boat's going to rock. If you're not applying equal pressure, the boat's not going to go straight. And also the idea is to get 2, then 4, and then 6, and then 8 of these on the water so that we can go out and train next fall in these boats. And you know, they cost about $250 a piece to build. So if you guys bump into the bridges and crash into each other, I really don't care. It actually would be fun to watch. So in order to build a boat, there are a couple of decisions I had to come up with. And some of them would be, I wrote them down so I wouldn't forget. TB or MB. TB is the turn of the bilge, turn of the bow rather. So let's say, to make it simple, if a boat would be built, it would look like a diamond for the most part. The turn of the bow is right here. It's also referred to as the MB, which is the maximum beam of the boat. Now, these are two terms that I pretty much just made up, but they make sense. So the turn of the bow. And if you look at a boat, it's kind of fun to find it. You just watch where the bow is going out, 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 and you will find a very distinctive turn where the boat then starts moving towards the stern. So it goes leading edge, maximum beam, or turn to the bow, and it goes to the trailing edge or the stern. So I determined the maximum width that I want this boat to be. I had to determine the length of the boat, and I had to determine the balance or the midsection of the boat. All these are very important when you're designing a single. Those of you who've had the misfortune of rowing the flying pizza wedge, you know exactly what happens if I don't pay attention to these very simple design ideas. The boat just doesn't float well. It's still rowable, but it doesn't float well. So what I've done so far is I had to determine what hull shape is the best. Now, if you build a racing single, it's going to have flat sides. Sorry, I'm holding my phone. It's going to have flat sides, but it's going to have a rounded bottom. Now, that right there is a Vespoli racing shell. This would be the bow, and as you get closer and closer to the bow of the boat, the lines get tighter, and this is what a Vespoli shell is going to look like on paper. All right, as a boat moves towards the bow, it becomes like a nice leading edge, and as the boat moves out, it gets fatter and wider, and the bottom of the boat is going to have a rounded bottom. Now that is your fastest hull design for any boat, unless it's going to be planing. If it's a planing boat, if you look at a lot of modern sailboats, it's a whole different ball game now. But if you're looking at the old style hull, rounded bottom, flat sides, that's your fastest boat. However, that boat is very unstable. If you want to build a very stable boat, then you're going to have a barge construction or a flat bottom boat. And that's why barges are built this way. One, it maximizes cargo capacity, but also the flat bottom makes it very, very stable. But if you want to have a boat that is stable when it's on keel, or when it's off keel, when it's set or when it's unset, then that type of hull design is going to have a flat bottom. Sorry, do it here. Flat bottom, but it's going to have flared sides, like this. That's exactly how the old aluminum launches were built. If you ever look at them, that's exactly what they look like. And that's the design came from the old fishing dories of the late 1800s, early 1900s, where the old schooners would anchor off the banks, and these guys would row off into the friggin' Atlantic Ocean, the Grand Banks, all day and fish. And they found this boat to be very, very stable. So what I've done in my boat is I've used this design to create a stable boat that is easy to set. And the reason why you have your flared sides, so that when the boat goes off keel, the side of the boat is going to hit the water sooner than the flat-sided boat, which means this boat is going to have more stability if it's rocking from side to side. So this hull design is the fastest hull design. This hull design is the safest, or sets up the best if you're in calm, flat water. This hull design with the flared sides is going to give you a boat that is both stable, and it'll be stable when it goes off keel. As a matter of fact, the further it goes off keel, the further it loses its set, the more stability you're going to get. So when I built my boat, I had to determine where exactly the turn of the bow was going to be. And from trial and error, I've learned that the turn of the bow is going to be right at the end of the tracks. That is where the turn of the bow should be. So when you design your boat, that's where you start. That's the maximum width of your boat. Then you determine your length. Now there's a proportion that you have to do when you build your boat. From the turn of the bow to the bow of the boat, it's usually going to be about 1 foot longer than it is the stern. So once you've drawn on your design table the turn of the bow, figured out your length, and then moved, let's say it's going to be 16 feet, you move 17 feet towards the bow and 15 feet up from the stern, and that gives you your building parameters. And then the next thing I had to do was I had to determine how wide the boat was going to be and how much flare I was going to have in the side. So the next thing I did was I built that. And that is the template that I put down on my design table at the turn of the bow, and that determined the flare of the sides and the maximum beam of the boat. And I built the entire boat around that. So what we have now is the shape of our boat, which is this. Okay, so what you can see here is what I've done is those are the bulkheads that I put down to the boat. This is my seat deck. And if you look closely at the boat, I don't know if you can see it or not, but there's a very distinctive part in the boat where it's going and it's moving, and it's going all of a sudden. You see how it just turns towards the stern, turn towards the bow, and that is pretty much exactly where the back of the tracks are going to be. So there's a turn of the bow right there. Now the shear of the boat, or the shape of the boat, is not flat. It has a bit of a rise to the bow and has a bit of a rise towards the stern. And that makes the boat look better in the water, and also the rise of the bow helps the boat break through the water. The boat is going to have external flared gunnels here. The full length of the boat gives it a lot of stability, but also when the water hits the side of the hull and moves upwards, it doesn't go into the boat. It hits the flared gunnel and goes away from the boat. So it gives you a little stability, and it helps keep the boat dry. So here's looking from the bow. This is the bow bulkhead being glued. The seat deck is just being temporarily laid on top of the bulkheads and put down with weights to help glue down the bulkheads. I just put them in. And these clamps here are closing the hull up alongside the bulkhead. What you see down the boat there is the keel. And what you see here are weep holes for water to run, fore and aft. And there we are. That's the boat. It's coming along. The next thing I'm going to do is roll the boat over, fair the hull on the outside, fiberglass the outside of the hull, and when I'm done with that, I will roll the boat back over, and I will then determine the shear line of the boat, which is temporarily marked here. As you can see, I think that's where it's going to be. I've designed that. And then I will glue this, I call it a tow rail. You can call it a shear clamp if you want to. You can call it an external gunnel. She goes by many names. I will glue that to the hull and then cut it down. And that's it. And then the boat is pretty much built. And the last thing I have to then determine is where exactly to put the tracks onto the seat deck, where exactly my foot stretchers are going to be. I have them temporarily here as a measurement. Where my rigger is going to be. I have to determine how do I connect the rigger to this boat, which is no easy task. And at that time, she's ready for floating. So I'm hoping to have that done in another week or two. Hopefully some of you guys will be here so that you can take it for a test spin.